you talk about the portion, when you talk about the portion called as polymers, right? When you talk about the portion of the polymers, right? Now, we have to understand that polymers are vital for us, right? Polymers are essential substances which are there, right? In our life, right? Is it? We cannot come out of polymers, right? Now, do you know what? Polymers, if you see, polymers can be divided into two parts based upon that who prepared it, right? How did it prepare, right? Who prepared it, right? So if you see that when humans have prepared it, right, we can tell that they're chemical polymers, right? If God has prepared it or nature has prepared it, we call it natural polymers, right? There are a lot of natural polymers we are having, right? We have the rice, we have the starch, right? There are lots of other natural polymers we are having, right? Now going to this thing now, next bit is that if we see that when we talk about this per polymers, these polymers will be divided into two categories, right? Based upon what is the process by which we had prepared it, right? We have to see that. Now, what exactly is a word called as polymer? Polymer is a substance containing very large molecules, right? Sorry, they are very large molecules, and they're consisting of monomers joined together, right? Now, next bit is that if you see that when we talk about any preparation of the polymers, right, we can divide this into other categories also, right? One was synthetic polymer, one was the natural polymer. The other category by which we divide, that is called as what? That is called as the addition polymerization or condensation polymerization, right? In your A levels or your IBDP, you'll be learning that addition polymers are what? Addition polymers are those prepared by addition reaction. What's the addition reaction? A plus B gives you AB. This is addition polymers we are having, right? What is condensation? Condensation polymerization is similar to addition polymerization, right? Suppose C plus D gives you CD, right? And a small molecule is eliminated. Usually it is water or HCl, right? Isn't it? So this bit we have to know, right? Now, the other important differences we are seeing, what? The other important difference is that in addition polymerization, right, we have to always take a single monomer, right? That's very important, right? A single monomer is taken. Only a single monomer has to be taken, number one. Number two, addition reaction has to occur, means we have to always take the single monomer as a alkene. This bit you have to know, right? Always a alkene has to be taken and a single monomer we have to take, right? Now we are moving on to the part of the condensation polymerization. In the condensation, this reaction, we don't take an alkene. This extremely you have to be clear about. We don't take an alkene, right? In addition polymerization, single monomer is obtained, is taken, single monomer. But in condensation polymerization, we do not take an alkene. Instead, we take two monomers, two different monomers. Usually, we take two different monomers. And second, the two monomers should have two functional groups. This bit also is important, right? Now, moving on to this thing, if you see that when we talk about addition polymerization, we have to take a single alkene, and alkene will be going through just now that we obtain from cracking, right? Cracking process gives you alkene, right? In the LC also, you'll be learning that we have to also know about the cracking process for the LCA part, for the polystyrene cup and the paper cup, which is better in LCA, right? So we get it from the cracking process, right? Isn't it? This alkenes. Only a single alkene is actually we have to take, and we get what? We get a polymer. Now, when we see how to represent this, right? When we see how to represent this representation is very important, right? If we see that there's a fixed number of monomers we have taken. Now, two important things are that repeating unit. Repeating unit is either this or either this. What is a repeating unit? Repeating unit is a way by which we represent the polymer. Now it differs. If you take a fixed number of monomers, we take a fixed number of monomers, you'll be having a repeating unit something like this. Please make sure that you are opening the hands over here, right? And see, they're joining, right? This joins, this joins, this joins, this joins, this joins, right? And we are getting what? We are getting a polymer like this, right? Fixed number of monomers. Remember this. But the repeating unit changes when we don't know that how much amount of the monomers we have taken, right? We don't know, right? What we have to do? We have to extend the hand outside like this, right? We have to extend the hand outside and we bring the n below. So this is the way we represent. And second thing is that we always have to represent the monomer in such a way that the double bond is always at the center, right? And all four hands you distribute like this, right? Isn't it? This is a very important part. Now, if you see that the different monomers we are taking, We can take what? We can take ethene, right? We can ethene from the cracking, right? We can take ethene from the cracking. We can take propene from the cracking, right? So the other alkenes we are taking what? We are taking chloroethene. We are taking tetrafluoroethene, right? So a double bond will be getting converted to a single bond, right? Like this, right? We are getting, see, here is the repeating unit of how many? We have taken over here one, two, three, four, right? There are four particular monomers we have taken. And the repeating unit will be what? Repeating unit will be simply like this. If you're taking n number of polymers, right? Isn't it? Now, going to this next bit, we have to identify the monomer also, right? Identification of this monomer is quite easy, right? We have to see that how it is repeating. See guys, I'm telling you that this polymerization or condensation reaction polymerization will be going to a very complicated level in your A levels or IBDP, right? So get your base very clear, my suggestion, right? Get your base very clear of this. When we identify the repeating unit, we have to just see where is getting repeated, right? And this is propene. See, propene you might be getting like this, right? See this bit is the most important trick you have to know. You might get a propene like this, right? Like this. So what we have to do? We have to arrange them, right? We have to arrange them. We have to arrange them, right? Into this bit, right? This is the way we are doing, right? Isn't it? Now, we are moving on to the part of condensation reaction polymerization, right? In the condensation polymerization, we know what? In the condensation polymerization, we know that we have to take two different monomers, right? That's very important. Two different monomers. Next, we do not take an alkene. This bit also is important. We do not take an alkene. And every monomer should have two functional groups at the end of the chain, right? This is the way we do, right? At the end of the chain, it should have two functional groups, right? And the reaction is what? The reaction is condensation reaction we are taking, right? In the condensation reaction, what happens? Two small molecules, they join to form a larger product, and a small molecule is water is eliminated, right? This bit, right? Isn't it? So this is the nylon preparation, right? In the nylon preparation, what we do? This Cl and this H gets eliminated, right? And we are getting what? We are getting a amide bond. See this nitrogen and this carbon will be forming a bond. See, this is the bond I'm showing it with pink, right? Isn't it? So this is a process by which we prepare nylon, right? In your book, we are having an example of the part called as polyester. In this polyester, what we do? Always remember that you might be given the hydrocarbon part to be symbolized as a as a box or a circle, right? So how to handle these type of questions? If you have got it as a box, right, to given. So how do you represent this? We represent in this into this manner. See, right? See, we are taking again. I'm telling you, just learn this trick that the OH group, right? The OH group of the carboxylic acid and the H of the alcohol, that's get eliminated, right? And the bond we are getting what? We are getting bond like this, right? Single bond O, double bond O, C, right? Means I'm opening up this bond, right? This bond which I'm coming, this bond we are getting over here, right? Like this. So we're getting ester bond. Now the trick which you have to learn is what? The trick which you have to learn is that we have to make sure that we are taking out the hydrogen. This bit is very important. You're taking out the hydrogen, not the OH. And from the alcohol end, we have to take out the OH over here, right? And here which is joined, right? We know that here is a joining, and OH and OH is getting eliminated, right? So we're getting a so we are getting a ester bond over here, right? Remember that you have to put 2n over here, right? We have to put 2n over here. Now, moving on to the part, we have to know that whenever we are taking a condensation reaction, a small molecule is eliminated. What's eliminated over here? We are getting that H2O will be eliminated, right? Over here, small molecule is eliminated. And we are getting a condensation polymerization reaction going on, right? Now moving on to this part, we know that if we see that when we utter the word natural polymers, right? The natural polymers which are there in the syllabus is what? They are starch, right? We are having starch. Also we are having DNA, also we are having, right? We are having the protein, also we are having, right? These are the natural polymers, right? The polymer is a large molecule which is made up of small molecules, right? Usually called as monomers. Now in the starch, what is the monomer we are having? We're having C6H12O6, right? This is the monomer we're having, right? And the monomers will be joining, right? The monomer will be joining to form a polymer. Here, if you see that when we talk about, please try to open your book and mark this important, right? This bit. This bit is a prediction which we find, right? Of your questions, right? So we can see that the glucose molecules can join up to form starch, right? The glucose molecules get polymerized to give you the structural part of the plants, that is cellulose, right? In the starch we are seeing what? In the starch we are seeing that the amount of the monomers, you have to memorize this, right? There is 1500 glucose monomers we are taking. How many? We are taking 1500 glucose monomer over here, right? And we are taking a branch chains over here, right? They are branch chains, right? On the other hand, when you're having branching, right? When you're having branching, the branching won't allow the intermolecular force of attraction to exhibit well, right? We discussed also that when we talk about intermolecular force of attraction depends upon what? Can anybody go to the Zoom chat and send me intermolecular force of attraction depends upon what? What are the three important characteristics intermolecular force of attraction depends upon? Please, everybody go to the Zoom chat and send me a message quickly, right? What are the three ways by which, or whatever you know, what are the ways by which the intermolecular force of attraction depends upon? Hmm. And please open your book quickly and write down with this page. You study page number 224, right? Thank you so much. Okay. Okay. Can you send me? Okay, fine. Okay. Who sent me message? Okay. Ishani is the fastest finger. Mokshi is the fastest finger also, right? Wonderful. Kritik, wonderful. What size of the molecule, right? Isn't it? Right. Somebody's in atom, size of the molecule. Wonderfully right, right? Uh, what about Nithila? Nithila, what about you?
I've sent it.
Yes, 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 yes. Thank you so much. Thank you so much. Thank you so much. So that's a very important point. We have to know that intermolecular force attraction depends upon the size of the molecule, right? Second important bit, you have to memorize this. The intermolecular force attraction depends upon the branching. You note down this bit of the A levels. This is required over here, right? Branching, right? Branching means what? If the molecule is a straight chain, right? If the molecule is a straight chain, more intermolecular force of attraction will be there. If the molecule has got branch chains, the intermolecular force of attraction decreases. Because why? Because in the branching, if the chain is branched, right, the molecules cannot come closer and exhibit the intermolecular force of attraction, which happens in a starch over here, right? In the starch, we are seeing this, right? Right. Thank you so much. Now moving on to this part, we to see that if we see that in the cellulose, what happens? See, in the starch, 1500 monomers joined. In the starch, how many monomers will be joining? Approximately more than 10,000. That's not all. The monomers chains, the polymer chains are will be what? Are having straighter chains. Thus, they can form intermolecular force of attraction, right? See, how does a tree stand? Because of this cellulose, right? So the intermolecular force of attraction can exhibit when the whole chain is not branched, right? So that's the thing we have to master. Finally, we are going to this part of what? Finally, we are going to the part of the what called as proteins, right? In the proteins, we understood that in the proteins will be having what? The proteins will be having an amino acid as the monomer. What's the amino acid? Amino acid will be having NC COOH. It will be having NH2 and R, right? This R group changes, right? You might be knowing this. The R group changes. Means you can have CH3 over here. We can have C2H6 over here. This group changes. Otherwise, the all other portion of the amino acid remains the same, right? If this R group is hydrogen, right? Hmm. This is called as glycine, right? So they have shown you the glycine polymerization, right? So same thing happens, right? That what happens over here? The OH group, right? And the H group, right? This will be eliminated and will be forming what? Forming H2O. And where the bond forms? The bond will be forming in this direction, right? H and N, right? Sorry, C and H. Sorry, C and N, right? This bond, right? This bond. And we're getting an amide bond. So a protein is also called as a polyamide. We call it as a polyamide also, right? Now moving on to this thing, we have to see that if we see when we call the addition polymerization, right? The addition polymerization requires alkenes, right? Just I'll be showing to this. They require alkenes. And from where the alkenes undergo? They come from the cracking. Now, what exactly is a cracking? In the cracking, we have to understand that when we take a cracking, right? The cracking will be giving off what? Always a alkene. So what exactly is the process by which we do this? Just 1 minute. I'm opening the page so that I can navigate quickly. Oh, fine. Here you go, right? This is 250. Fine. See now. Now in the cracking, why do we do cracking, right? We have seen that in the crude oil, they contain mixtures of hydrocarbon, right? There are many mixtures of hydrocarbon, right? Crude oil. We cannot use crude oil on its own. So what do? We heat the crude oil to the boiling point, right? At around 400 degrees centigrade. All these fractions from C1 to C100, right? They all convert to what? They all convert to gases, right? They all convert to gases. When they convert to gases, right? What happens? They will be going up, right? The top part of this fraction distillation column is kept at a lower temperature, 25 degrees centigrade we get, right? Now, we learned that as everybody was wonderfully answering, that if the chain length increases, right? Please try to take out a Zoom chat and send me a message, please. If the chain length increases, what do you feel? The intermolecular force of attraction increases I or decreases D? Please try to take the Zoom chat and send me. Thank you so much. Nithil is the fastest finger. Hanshika is the next, right? Wonderful. Kritik is the next. Wonderful. Ishani, Jackie, wonderful. Amazing, amazing, guys. Amazing, amazing, amazing. Very good. Hitakshi is also very good. Mokshi is also right. Microseconds. I'm very proud of you. Yes, increases, right? The boiling point increases as the molecule size increases, right? What happens? The highest boiling point will be the longest chain which you're having, right? Largest molecule. So this will be getting condensed first. So we separate them out, right? Isn't it? Now always remember that smaller is the carbon chain, right? If the chain is smaller, more better is the fuel, right? We knew that if we take a smaller chain, it will be having a less amount of boiling point. It will be having more volatility, right? Isn't it? We see that it will be having more runniness, right? Runniness, less viscosity. It will be having more inflammability, right? So what about if you have got more fuel oil fraction? What about if you have got more diesel oil fraction, right? Can we convert this into petrol, the much more better fuel? Yes, we can. What we do? We do a process called as cracking. Cracking is a process by which we are taking, suppose we are taking a scissor like thing, right? We're taking a scissor like thing, and we are trying to cut this, right? Isn't it? So there are two processes we have to understand, right? The both the processes will be employing this reaction, right? Cracking always produces a smaller chain hydrocarbon, right? And with it you have to get two alkenes, or alkenes is obtained. See, this is the source of the addition polymerization, right? See, cracking is very important in the industry, right? We have to drive our cars, buses, aeroplanes, right? So there are lots and lots of millions of ethene which is obtained, right? Isn't it? So that's the reason the main polyethylene is sourced from what? The cracking. And remember one thing, in the LCA part, cracking will be taking a smaller amount of energy, right? Right, it will be taking a lesser amount of energy. So the energy aspirations of the LCA part, we have to note down that cracking will be taking lower energy, and it's better for the LCA, right? Isn't it? Part, right? Isn't it? So we are getting what? The alkene over here, right? Now, when we talk about the two different types of cracking, right? We have to understand that what are the two different types by which we can do it. The two different types by which we can undergo cracking is, one is called as the catalytic cracking, one is called as the steam cracking. In both the processes, first we take the crude oil fraction, suppose we are taking decane, and we are converting into a gas. This will be same for both the processes. In the next process, we are doing what? We are trying to add a catalyst, right? Catalyst, right? At a lower temperature. And we get what? We get that smaller hydrocarbon. Second is that we can also mix this gas with steam and then go for a high temperature, right? And we get cracking. So both these processes are using high temperature. So we call that this process as the thermal decomposition reaction, right? And both these processes will be giving you alkene. Now, guys, can you just go to the Zoom chat and tell me How can you prove that an alkene is obtained? Please write down the entire 2 mark question. Suppose what is the confirmatory test of alkenes? Please send me a message, please. What's the confirmatory test of alkenes? Jackie is the fastest finger. Wonderful. Very good. Very good. Ishani is the next fastest finger. I needed specification, right? That bromine water turns orange to colorless, right? Nithila, where are you? Where are you? What happens? Oh, Nithila has sent, right? Thank you so much. Yes. Thank you so much. Hanchika, Hitakshi. Very good. Very good. Very good. Mokshi, where are you? Where is Kailash? Where is Kailash? Everybody participate, right? Everybody participate. Yeah.
So I sent it.
Yeah. You sent me. Yeah, send me. You send me a direct message, right? Kailash, send me a direct message. Not to everyone, right? Isn't it? And this Kailash. Kritik, have you sent me? Kritik? Yeah, Kritik has sent, right? Ishani has also. Wonderful. Orange to colorless. Wonderful. So addition reaction occurs, we know that addition reaction occurs, right? And we are getting what? We'll be getting the cracking part, right? Isn't it? Sorry, the alkene will be tested, right? So that was all about what? That was all about the addition polymerization, condensation polymerization, and cracking, because we need alkenes as a backup, right?